Hi guys, so let's continue with the limiting reactant. And this topic at the same time simple, but students faced with many troubles. And before we start, just wanna ask you a question. How many bicycles you can build if you have two frames and two wheels? So obviously guys, you can build only one bike, because for each frame you will use two wheels. In chemistry, frames will be excess reagents and wheels will be limiting reagents. So the second frame absolutely useless if you don't have two extra pairs of wheels. That's why you will use limiting reactants, so limiting reagents, in order just to count the number or amount of the product. Okay, so if you have two wheels, you can construct one bike. The same in the chemistry, but the question, how you can find the excess and limiting reagent? So, question number one, how many grams of carbon dioxide will be formed if 35 grams of cyclohexene reacted with 45 grams of oxygen? They provide you with the values of cyclohexene and value of the oxygen. So you have 35 grams here and you have 45 grams of the oxygen. In this situation, guys, in order just to find limiting and excess reagents, first of all, you need to start with a balancing of equation. So it's a zero step, yeah? So the same situation as we did in the previous example. On the right side, you have odd number of the oxygen. That's why I will recommend you multiply hydrocarbon by 2, because in order just to save your time, yeah? So now you have 12 carbon, on the right side you will have 12, on the left side you have 20 hydrogens, so now you have 20 on the right side, and the last is oxygen, so here will be 24 and here will be 10, so the sum will be 34. So in order to get 34, you will multiply 17 by 2. And after you will balance the equation, you can start. So let's do our calculations. Mole equal to mass divided by molar mass. Mole equal to mass 35 gram divided by molar mass of cyclohexene. So in order just to find the molar mass, 12 multiplied by 6 plus molar mass of hydrogen 1 multiplied by 10. And you will find that molar mass equal to 82. Here you can use your calculator. So 82 gram mole minus 1. So guys, again, using your calculator, you'll find the value, but do not erase it, just save it as an answer. Okay, so you will get 0.427 moles of cyclohexene. The same you will do for oxygen. Okay, so the number of the mole will be equal to mass divided by molar mass, and mole will be equal to 45 gram divided by molar mass of oxygen, so it will be 16 multiplied by 2, it will be 32. Yeah, so divide by 32 gram mole minus 1, and if you do calculation, you will find that here will be 146 mole. After you find both of the moles of the reagent, how you can define which one will be excess or in the limit? The calculation, guys, very simple. So what you will do, just divide the mole number by its coefficient. Yeah. So 0.427 divided by coefficient, it will be 2 here. Yeah. So divided by 2, you will get 0.21. Yeah. And do the same for the oxygen. So 1406 divided by 17, you will get 0.083. So, okay, so now you have two values. Which of the value will be smaller? It will be limiting reagent. Which one will be bigger? It will be excess. So this value is smaller. That's why you assume it as smaller, yeah? So it's smaller, so limiting. And this is a bigger value, it will be excess. Okay, so one more time, guys. If you will divide the number of the mole by its coefficient, you will find the value. Which of the value will be smallest one? It will be limiting. Which one will be biggest? It will be excess. So we will require only limiting. That's why you can erase everything and just write here that this one, the mole of oxygen, will be assumed as limiting, because we will use it to calculate the number of the mole of the carbon dioxide. So we can move to the second step, and here we can find the number of the mole of the carbon dioxide in order to find its mass. So just let's move to the right side. Okay, if you have this number of the moles, what will be the number of the mole of carbon dioxide? But you know that when you spend 17 molecules of oxygen, you produce 12 molecules of the carbon dioxide. Again, the simple proportion is here. 17, it's 12. 1406 will be x. So x will be equal to 1.406 multiplied by 12 divided by 17. So the number of the mole will be equal to 0.993 mole of carbon dioxide. And the last one. In the last step, you will find the mass. Okay, so mass will be equal to mole multiplied by molar mass. So mass equal to mole number. It's 0.993. I will not write the units because of the lack of the space. Multiplied by molar mass of the carbon dioxide. So carbon will be 12 plus 16 multiplied by 2. It will be 44 gram per mole. So use your calculator to find 43.67 grams. Okay, guys. So when you will use 35 gram of cyclohexene, and when you will spend 45 gram of oxygen, you will produce 43.67 grams of water. If you have any question, just let me know in the comments, and we will move to the next question. In the next question, they ask us, what is the mass of magnesium oxide if 2.2 gram of magnesium is reacted with 4.5 decimeter cube of oxygen at STP? Here, guys, you can see STP, so automatically you will apply the third formula in order just to calculate the mole of the oxygen. Okay, equation already balanced, so we can start with our calculation. You are provided with a mass 2.2 grams of magnesium, and you are provided with a volume of oxygen. Again, guys, you will find the mole for both of them, and in order just to find it, in the first step you will use mole equal to mass divided by molar mass. So mole equal to 2.2 divided by molar mass of the magnesium. Molar mass of the magnesium from the periodic table, it's 24.3, yeah? So you can divide it by 24.3. Here you will use gram, here gram, mole minus 1. So mole here, guys, will be equal to 0.09. Okay, let's write one more, so 0.91 mole. Okay, so we will get the number of the mole of the magnesium, and the same you will do for oxygen. Here you will use a third formula, so volume divided by 22.7. So mole equal to the volume of oxygen 4.5 decimeter cube divided by gas constant 22.7 decimeter cube divided by mole. Okay, so here guys you will get using the calculator 0.198 mole. Okay. From this valve and from this valve. So the question, how you will find the excess and limiting reagent? Again guys, you will do the same, just divide this value by 2 and you will get 0.045. If you will divide this value by 1, because coefficient here will be 1, I mean before the oxygen, you'll get the same number, 0.98. So which one will be bigger? You will expect that this value will be smaller and this value will be bigger. We will use smaller value as a limiting reagent. Yeah? So you can write here limiting, and the second one will be excess. Let's erase our calculations because we got the result. And now guys, you can find the molar mass of magnesium oxide. Just let's write this. Okay, so when you will use 2 molecules of magnesium, you will produce 2 molecules of magnesium oxide. So it's 1-to-1 proportion, and here we can do our calculation. So 2 equal to 2 and 0.091 equal to x. So x equal to 0.091 multiplied by 2 divided by 2. So first 0.91 multiplied by 2 divided by 2, and you will get the answer. Okay, so answer will be the same because you can just cancel them. Okay, and here you will get 0.091 mole. And the last step, in the last step guys, you'll find the mass of the magnesium oxide. So mass will be equal to mole multiplied by molar mass of the magnesium oxide. Yeah, so mass equal to 0.091 multiplied by molar mass of magnesium oxide. It's 24.16 will be equal to 40 gram mole minus 1. Guys, here I don't follow the decimals because the aim of the video to show you the method, the way of the calculation. But here molar mass in the periodic table will be 24.3. Yeah, so when you will do your calculation, you need to be more accurate and follow the decimals. And here you will get 365 grams. So the mass will be 3.65 grams of magnesium oxide. So guys, first step, again, you will do both of the calculations using the different formulas to find the number of the mole. The second step, it's a simple proportion. So here it will be the simple proportion. This is the second step. And the third step is just reverse calculation. Yeah. So guys, I hope it's clear. Let's solve the last question. 2.5 gram of the hydrogen reacted with 30 decimeter cube of carbon monoxide. Again guys, here at STP. So automatically you will apply the third formula. What is the limiting reactant? The first question, what mass of methanol produced? How much excess is left? Okay, so let's start from the balancing, but equation already balanced, and you can start to solve. Yeah, so you have 2.5 grams 2.5 grams of hydrogen and 30 decimeter cube of carbon monoxide. Yeah, so the mole will be equal to volume divided by 22.7 because here it at STP. Yeah, at STP. So the second one it will not be at STP. That's why you will use different formula. Okay, so mole equal to volume. It's a 30 decimeter cube divided by 22.7 decimeter cube mole minus 1, and you will get 132 mole. Okay, so the same you will do for the hydrogen. So let's change it for the hydrogen. So mole will be equal to mass divided by molar mass here. So mole equal to 2.5 grams of hydrogen divided by molar mass. It will be 2 gram divided by mole, and you will get 125 mole. The point here to find the limiting reactant. How you will do it? You can just divide the first one by 1, so you will get the same number of them all, because coefficient here will be 1. And the second one, you will divide 125 by 2. If you will divide by 2, you will get 0.625 mole. Okay, so which one will be smaller? It's kind of obvious that this value will be smaller. Yeah. So that's why it will be assumed as a limiting one. So you can just erase everything and write here limiting. So you will use the mole number of the hydrogen in order just to do our calculation. In the second step, you need to find the mole of methanol. Okay, how you will do it? Same procedure. 2 here and 1 here. Yeah. So if here 125, what will be mole number of the methanol? 125 multiplied by 1 divided by 2. Okay, so you will get 0.625 mole. The last step, you will find the mass of the methanol. Mass will be equal to mole multiplied by molar mass, and mass equal to 0.625 multiplied by molar mass methanol, 12 plus 3 plus 16 molar mass of oxygen plus 1. Okay, you will get 32 gram mole minus 1 multiplied by 32. Mass will be equal to 20 grams. I hope, guys, it's clear now that first of all you'll find the number of the moles. So you will use the first step for both of them. You'll find the number of the mole. After you'll divide it by the coefficients. So, and you will find the limiting one. So limiting reactant. After you find limiting, you can forget about the excess one. You will just use limiting reagent in order just to find the amount of the product. In the second step, it's a proportion. Yeah, so here it will be proportion. And the third step, it's a back calculation. So thank you very much, guys, for your attention, and we will continue with the